system can be studied using analytical techniques depends on the property of the systems. There are certain principal properties that numerous systems share, whether they are continuous or discrete time. And comprehension of these properties permits a designer to devise tools which can be used for the analysis of particular system. This one later on. So in this section, we're going to look, first half of the class, we're going to look on the basic system property, which are system with and without memories, invertibility and inverse system, causality, stability, and the last two, time invariance and linearity. And then we will go into the last two properties, which is very crucial, and we'll be using that throughout the courses. Okay, so let us look at the first one, basic property systems with and without memory. A system is said to be memoryless if its output for each value of the independent variable at a given time is dependent on the input at only that same time. Maknanya dia at ketika itu sahaja. So example yn, this is for discrete. Kalau kita ada bracket begini and then n instead of t, it is discrete. So example yn equal to xn minus x square n square. As we can see here, the time or the apa, kita punya variable di situ adalah n, and this is example of a resistor is a memory. This is one example of the memoryless lah. Another example is that a resistor is a memoryless system with the current IT. This one for time variable is the input, and the voltage VT is the output of the input-output relationship of a resistor. So kalau kita ada Ohm's law, VT equal to RIT at that particular time. Okay, the identity system is also example of memoryless system. Okay, so kita ada YT equal to XT. Maknanya dia apa? Bergantung kepada at that particular, the same time. Okay, the concept of a memory in a system corresponds to the presence of a mechanism in the system that retains or stores information about input values at time other than the current system. For example, sama kalau kita ada equation yang melibatkan summation, okay, and then usually summation ni it looks between minus infinity to n minus 1. Macam dalam case ni n minus 1 lah. Maybe also plus and whatever the limit here. And then kat sini kita kata, thus if we simplify this equation, we have this equation. Therefore, the accumulator remembers the running sum of previous input values, which is the preceding values of the accumulator output. Jadi dia ada apa orang kata accumulate. So not kalau tak ada, maknanya at that particular time, at that particular instance only, the system is memoryless. Okay, another example, a delay. A delay is a system with memory. Kita belajar pasal delay, advance and so forth. Also example of system with memory. So a capacitor, remember we learned about how to design, how to draw the waveform of a signal. A capacitor is an example of a continuous time system with memory. The current is the input and the voltage across the capacitor is the output. Dia ada integral. Sini bila dia integral tu dia ada mengambil kira previous time or future time. So dalam case ni adalah previous time. Okay, in many physical systems, a memory is directly associated with the storage of energy. A capacitor stores energy by accumulating an electrical charge represented as the integral of the current. Jadi the integral tu dia mengambil kira the previous time. Consequently, RC circuit has memory physically stored in the capacitor. Okay, another category is another property is the invertible and non-invertible. So what does it mean? Let's say we have input xt and output yt. If it is one-to-one mapping, it is invertible. If it is many-to-one mapping, it is non-invertible. For example, ni example of invertible. This is an example of non-invertible. So let's say we have here a system with yt equal to xt plus 2, and then if we map here, it is 1 to 1. Whereas another example, yt equal to x squared t, when we map, it is many to 1 mapping. So this is an example of invertible and non-invertible. Okay, invertible and inverse. What about inverse system? A composite system consists of invertible system and cascaded with inverse system. Okay, what does it mean by inverse? Okay, let's say we look here, we have an invertible system here, one-to-one mapping, xt pergi kepada yt, and then we have inverse system. Inverse system meaning that if the output, the transfer functions or the gain of the system is h1, and then when we have an inverse system, that inverse system, the gain will be 1 over hs. Okay, so this is what is called invertible one-to-one, and then one-to-one again for the inverse system. So this system is having invertibility and inverse property. Okay, this one we will be using in the application later on. Okay, so the first thing is to understand the concept first. Okay, we also learn about causality. Okay, we also learn about causality. So causal system, output of system is independent of future values of the input. So we have more example last time. So for example, like this one, yt equal to xt. Another example, yt equal to xt plus xt minus 1. So this is fall under category of causal because output of system is independent of the future values. So non-causal, output of system dependent of future values. So examples for the non-causal are listed here. So for example, like yt equal to xt plus 2, it depends on the future input. Okay, so y, for example, like y at t3, it depends on x3 plus x5, the future input. For another example, example 2, yt equal to xt plus xt minus 1, this one based on past, but we have one components here, depends on future, so therefore the system is fall under category of non-causal. So anti-causal system, output of system depends only on future values of input. So this is on causality. Okay. Another properties which is also important is stability. Stability, if for example you want to analyze how stable your system is. So to have the stable properties, it should have bounded input and bounded output, ataupun dia punya short form is BIBO. Okay, for a stable system, output should be bounded for bounded input at each and every instant of time. Let's say time is from minus infinity to infinity. So the amplitude for output is finite, amplitude for input is finite, each and every instant of time between minus infinity to infinity. So for example, example of bounded signal, kita ada DC signal sin t, cosine t, ut. For example, like DC signal, kita just have a constant value of 6V, yeah. And then kalau kita tengok cos and sin, so usually the amplitude between -1 to 1. And then for ut, we just have one output, which kalau u2 means unity, the value is 1. T less than 0, the value will be 0. So ut ni ataupun unit step usually 0 to 1. So unstable system, system with bounded input but the output is unbounded. Dia tak ada apa, tak bounded lah. Jadi sistem tu kita tak boleh nak agak stability dia. So for example like this one, saya tunjukkan this is example. Whether the system is stable or unstable, kita ada yt equal to txt. So xt, katakan kita punya xt adalah 5 volt, but then when we times with t, which is unbounded, so therefore the system will be unstable. Okay, so this is an example. And another example, so this one, whether the system is stable or unstable. So let's say kita punya xt adalah DC value. So bila kita tambah dengan 2, so it will be 6. So system to bounded. The same or the same for sine, the cosine, dia ada dia kata apa? bounded output, so therefore kita boleh tengok dia punya the system is stable. Okay. So far so good, class?
Yes, doctor.
Yes, Doctor.
Saya teruskan. Okay, this two properties also important, linearity and time invariance. What does it mean by linearity? Okay, linearity ni macam ini ya. So if we have x1 equal to y1, x2 equal to y2, and then if we have x equal to ax1 plus bx2, so our equation will be like this: a y1, x will be a y1 plus b sepatut aduh okay. Okay, macam mana saya buat ni, ay1 plus by2 so this holds for all possible inputs and for all t. And then for time invariance, the property is something like this: if you have xt with the output of yt, bila kita ada t minus t, so the output will also t minus t for all possible inputs and for all t, capital T. Okay, so while these two, especially these two, the linearity and time invariant is important, because this LTI, the combination of linear and time invariant, are the system that we're going to look throughout the course. So when the system having the linearity properties as well as time invariant properties, the system is called linear time invariance. Linear systems are system, kita define balik semula. Linear systems are system whose output for a linear combination of inputs are the same as a linear combination of individual responses to those input. Maknanya linear combination of individual responses ni output dia lah. So maknanya kalau input dia tu adalah the combination of inputs, so dia akan produce the combination the same for the combination of output. Time invariant system are system where the output does not depend on when an input is applied. Jadi kalau kita tengok xt minus capital T, so dia sama, dia tak kisah bila dia akan dia hold that invariance properties. So a system with linearity and time invariance property is called a linear time invariance, which make LTI system are easy to represent and understand graphically. Jadi bila kita ada for this properties, kita boleh we can predict what the future will be when the system holds this linearity and time invariance properties. Okay, so the input and output to LTI system of interest to us are function of time, shown usually xt and yt. So and again the system, it covers single input and single output system. Okay, so before saya pergi kepada more example on LTI, we understand the concept of the linearity and time invariant first. Okay, so if we understand these two concepts, then we can look into the system as a whole, the LTI system as a whole. Okay, for example, this one sama nota saya dengan your opinion, ada sedikit yang saya buang lah supaya that you can write something lah, kalau tidak dengar je kan. Let me look at, saya letakkan sebelah-sebelah Okay, if you notice, I also shared the link for Monday's for last class, which was on Monday 20 berapa gitu, 29th So, saya baru letak satu sahaja video. This one saya bagi tapi nanti later kot. Okay. Okay, we have this linearity. Kita ada sistem. Sistem kita adalah yt equal to kxt, where k is a constant value. So you want to determine whether the system is linear, whether the system is it time invariance. So go back to the definition. Linear apa dia? Dia punya combination tu akan memberi linear output. And then what about time invariance? Okay, so to do that, we test for the linearity. So let's say kita ada X1 which will produce Y1, and then it still hold. The system is actually the output with some constant. Okay, so let's say the constant is the same, K. So X1, um, so Y1, based on the equation here for this example 3.1, the Y1 is input with a time with some constant value. So is this system, this type of system, nanti kita akan jumpa banyak is this type of system, is it linear, is it time invariant? So to test the linearity, kita tengok the combination. Kalau kita lihat balik semula the linearity, linear system are system whose output for a linear combination of input are the same as a linear combination of individual response to those output. Jadi kalau kita buat satu-satu, for example like X2, let's say X2 we multiply with K, so we have Y2, and then the X is actually the combination of these two, AX1 plus BX2, and then bila kita masukkan dalam kita punya sistem, sebab kita tahu X adalah this equation, and then we come up with this one, A KX1 plus B KX2, which is actually A Y1 plus B Y2, the same thing. Maknanya dia still whole lah. Okay. If we multiply by any coefficients, kalau sistem yang X plus constant value, so it holds in terms of bila kita ada combination of linear equations. So therefore this system fall under linear system, because as we shown here, y equal to a y1 plus b y2 for all a, b, x1 and x2. What about linearity? Time invariant. So let's say we have xt, k, xt. Sebab kita kata tadi for this example, the output is multiplied by a constant k. Okay. So what happen if kita ada time invariance? Time invariance ni maknanya ada t with some value like this one, capital T. Jadi bila kita masukkan kepada our equation for the y, k x t minus capital T, so this one it holds. It holds. So meaning that the system is time invariance because shift property is valid for all capital T and T. Okay. Kita tengok another example. Tapi kali ini the x is times multiply with the constant k1, but then we have additional k naught here. So kalau sistem yang begini, is it linear? Is it time invariant? So again, we test for linearity, we test for invariance. So kita tahu tadi y1 is the combination of x, the input with multiplied by constant plus another constant. So that one holds for y1, that also holds for y2. And then bila kita masukkan dalam x dan y, adakah dia sama? So when we do that, kita tahu x, kalau linearity dia mesti a x1 plus b y2 x2. So bila kita masukkan dalam kebersamaan k, kita dapati dia tak whole, dia tak sama. Okay, because k tu dia akan jadi value lain. It is not k naught. Okay, so therefore this system is not linear. But then bila kita test for time invariance, yes, it is falls under category time invariance. So you can look here how the system, sebab dia yang apa, t dia masih lagi t minus tau. Yang ada k naught tu kita tak kacau because dia tak ada melibatkan t, time. Okay, so there are examples here. Saya rasa due to because kita nak buat beberapa exercise on LTI nanti, superposition. So I give you some questions here. Example, this is from textbooks. Example 3.3, 3.4 and 3.5. The same thing with xt is the input and yt is the output. So with this type, of equation defined by given. For example, like yt for 3.3 examples, yt equal to integral of x tau d tau, 3.4 yt equal to t integral x tau d tau, and then finally dyt over dt plus this one is a basic ODE equations yt plus xt. So kita nak tengok whether the system is linear or not, whether the system is time invariant. So please do that for the test for linearity and test for invariance. Dan kita tengok whether dia adakah the system is linear or and time invariance. So I did give solutions for 3.3. Okay, for the rest 3.4 and 3.5, please try back home, and if you have problems, you just can maybe start discussing among your friends first, and then kita boleh tengok nanti later on. Okay, so this one for integral. Integral kalau kita buat satu persatu, test for linearity, test for invariance, yes, the system is linear as well as the system is time invariance. What about the next two examples? So I want you to try. Ada soalan?
No, Prof.
Okay, so I continue. Okay, so we discussed on the properties, basic properties of the system just now. And then I mentioned to you that the linear and time invariance are the one that we much interest on. Because if you look at linear time invariant system, or usually short form for it is the LTI system. So why does it important? Why does it is of our interest? Okay. The response of an LTI system to a large class of inputs can often be predicted from its response to a single input. That is why, because if we have an LTI system, if we have an input, kita boleh menggunakan dia punya properties tu to predict what is the response ataupun what is the output based on whatever the input that we put into this LTI system. Okay, sebab itu sebenarnya adalah as an engineers lah, kita nak tengok how the system behave whenever any types of inputs that we put into our system. Okay, so therefore an LTI system often may be described as an input-output pair. Okay, sebab kita tengok between the relationship the input and the output. Then kita nak tengok how it behave. So that's why kita kena understand the properties tadi, the classification, the interconnection, so that it helps us to understand the system as a whole. Okay, so bila kita kata kita ada LTI system, we have the inputs, so we can have the predicted output. The most commonly used description is by the system impulse response. Okay, so before going further with whatever the output that we put, kita tengok dulu kepada impulse response. Impulse masih ingat lagi tak kelas? What is the impulse? What does impulse mean? Ingat lagi impulse? Impulse signal? So today is 1 April. Okay, remember kita ada unit function. Yang kita ada impulse, one of it is impulse, and then we have unit, and then we have rem. So kalau impulse di sini Usually the symbol is, kita panggil sini delta. Okay, let's say unit impulse. Unit impulse maknanya dia satu lah. Okay. Untuk to understand better in terms of the application or the physical, kita boleh kata apa ni, impulse ni macam hammer lah. Dung, ada bila kita letak vibration, kita ketuk, and then we want to look at the response in terms of vibration, for example. Ataupun banyak lagi example macam sebelum ni saya bagi previous example is a bump jalan bump, then kita nak tengok the response. So this is impulse. Okay, if the impulse response is known, the output system can be determined for any input of the system. Okay, so bila kita tahu impulse di sini, maknanya impulse ni satu. So let's say this is our system, we describe by block diagram. LTI system. Okay, usually kita describe input xt, the output is yt. Okay. So as a basic, kita kata here our input is an impulse. So output kita sekarang adalah impulse. Okay, so impulse response of an LTI system is the output yt when the input is the unit impulse. Jadi kalau kita tahu bila dia unit impulse, so whatever yang kita masuk di sini, the y will be whatever sama dengan the output, because it is impulse. Impulse yang unit impulse satu. Apa yang masuk itu yang keluar. So in this case, okay, the response here is called the impulse response, and usually we represent it by ht. So dalam case ini, impulse response of the system is ht due to the input of the impulse tadi, delta t. Okay, so bermakna di sini ht is actually explaining the behavior of the system for the impulse input. Therefore, ht is referred as the impulse response. Okay, for this particular impulse input. So ht ni kita panggil sebagai impulse response. Okay. I need you to understand this concept first lah. Maknanya nanti bila saya kata impulse response tu adalah the output of the system when we put the impulse input, delta t. Okay, I proceed. Class, boleh? Okay. So why this is so important to us? Throughout nanti kita akan buat convolution, kita akan buat Laplace, we will also discuss on the Fourier transform. So let's consider an LTI system with input xt and output yt. So ni kita punya LTI system with the impulse response here kat dalam, which describe the behavior of the system. So the impulse response ht relate the output to any input. So ht, or we call it as impulse response, dia sebenarnya adalah yang membayangkan menceritakan what is the relationship between the input and the output. So ht is very important in this case for us to understand the behavior whatever the input yang kita masuk. So dalam case to find the impulse response, you will learn about convolution. So chapter 4 and chapter 5. I don't have the textbook. The textbook is at home. So the to understand about the concept of impulse response, you will learn about convolution. Convolution, kalau kita lihat di sini, So what is actually YT? YT is the combination or the convolution of whatever the XT that we have with the impulse response of our system, HT. Okay, so we learn about the linearity, we learn about the time invariance. So this thing will hold to the bila kita masuk convolution nanti. So from here kita tahu, kita nampak lah sini YT equal to XT convolve with HT, the impulse response. Whatever the things inside this yang describe the our system. And then once we're familiar with this is in times response, we will move into finding what is the transfer functions. How are we going, sebab bila kita dah nampak uh, the relationship here, next step will be understanding the behavior of the system ataupun kita panggil transfer function. Kalau if you look here, transfer function is actually describing the system. So whatever the input yang kita masuk, kita akan dapat output. So how are we going to find, bila kita tahu apa-apa sistem, we learn about RLC, kan? Kalau electrical, kita ada resistor, inductor, capacitor. Kita belajar juga, we look also into the mechanical system where we have the friction, the force, using the uh, Newton's second law. So for this system, we will look dig into finding the transfer function. Kenapa nak transfer function? Sebab kita nak tahu the system punya behavior lah. So we're going to learn about finding the transfer function of any system, okay, using what we call Laplace transform. Okay, this kita akan touch few weeks before the semester break lah. So why Laplace transform, kita akan belajar semula mengenai the linearity concept and so forth. Where we have Laplace transform the output, selalu Laplace transform the notation kat dalam tu is the S. So YS equal to HS, XS HS. So the linearity concept here. So whatever the input with the times with the impulse response kat sini, ataupun transfer function kita panggil dalam case ini. And then we also going to look deeper into the frequency later on second half of the semester. Also finding the transfer function, but then in this case it is on the frequency response. So basically once we understand the concept of Laplace, to look into the frequency response, we just substitute the S with the J omega. And then ini kita panggil Fourier transform. Okay, doing that we use the Fourier transform equations ataupun properties ataupun rules. Later on you will learn that. Okay, so these are the connection ataupun the relationship, the impulse response, transfer function and frequency response. Okay, so bila dah ada konsep tu, so kita go back to the linearity, the time invariance. The behavior of a linear continuous time invariant system with input of xt and output yt is described by the convolution integral. So we understand just now, tadi saya cakap pasal time response convolution. So yt, kalau kita balik pada our system here, yt is actually the convolution. Convolution ni bila kita buat sebenarnya, when we look into the concept, it is actually integral. Kalau you all belajar integration dulu, integration tu apa dia? If you look at certain time, it is actually kita cari luas kawasan ataupun kita cari summation, right? Remember the concept of integration?
Yep.
Okay, so this is how it holds lah for this concept, for this LTI system. So in order for us to find what the output is, if we know the behavior, the impulse response as well as the input, so kita boleh dapatkan dengan menggunakan the convolution integral here. Okay, so where HT is the system response to an impulse and YT is therefore proportional based on this equation to weighted average of the input XT. So bila kita kata integral, okay, so dia adalah the summation of that. The weighing function x minus t simply shift by t as t changes. The weighing function emphasizes different parts of the input function. Sebab nanti bila you all kita lihat on the convolutions, we look the shift tu nanti, the shift of the t later on. So why that's why the understanding of the invariance tu tadi invariance, linearity. Linearity is multiplying nanti lah, XT dengan HT. Okay, in summary, the system linearity property allows the system response to be represented by continuum of impulse response, and the time invariance property allows that combination to be represented by the convolution integral. Okay, linearity tu membolehkan dia plus and then the invariance tu by the convolution integral. Okay, so that is the concept. Now let us look into the examples. Okay, use of superposition and other properties of LTI system. Okay, this is example 3.23 in our textbooks, Navi. So we have an input-output pair of any LTI system shown in figure 3.12. So if this is the impulse input and this is the output lah. So dalam ni dia letak DT and PT. Okay, the input-output pair for the LTI system. Okay, so now soalan dia, express PT in terms of DT, and then given the input rectangular pulse DT equal to UT minus T minus 1, and it is represented as bracket 1 ni, yang ni. Kat sini dalam buku dia pakai this symbol tetapi dalam saya punya nota, because I'm using latex, kalau simbol ni dia masuk dalam program, jadi saya pun tak tahu. Kalau siapa tahu latex macam mana saya nak keluarkan the symbol, so I have to make it bracket instead of, ni panggil apa pun saya tak tahu nama dia, parenthesis parenthesis ni saya, for my notes I'm using the bracket so it actually kalau dalam textbook dia menggunakan parenthesis ni. Okay, so given the input rectangular pulse dt equal to ut minus 1, kenapa ni nanti kita tengok. Consider input xt 1 minus 1 minus 1 using superposition, find yt, and then kita repeat the same system, tapi kali ni the input is 1 minus 1 minus 1, 1. Okay. Nak tengok saya bagi sampai mana. Okay. Jadi kita punya input YT, okay, input output pair, bukan input input output pair. So this is our LTI. Ada DT, in this case is DT and then the output here is PT. Okay, the DT ni dia bagi adalah 1 and DT, the equation is in terms of the unit function, sebab dia kalau yang ni adalah unit, remember unit function ni tadi, okay, sini ni impulse, kalau kita ada unit dia buka ke sini lah. Dia 0, time less than 0, and then dia akan maintain 1 throughout. kita tulis, usually kita refer sebagai UT. Kalau RAM tu RT. Okay, so this is unit. Maknanya ada satu. Okay, so bila kita ada square macam ini ya, remember the time shift and the time reversal. So this is dt. Okay, in terms of unit functions, how do we write this, kita panggil apa? Square pulse ni. In terms of unit function just now. Faham tak maksud soalan saya? Saya kecilkan kat sini, impulse. Ni saya nak besarkan sikit unit ni. So unit function saya pakai warna merah lah kot. Using red. So red. This is unit, the red one refer to the unit. Okay, so kalau we go back to the example tadi, sini, kalau in terms of kita dah belajar time shift, time reversal. So what is this equation in terms of unit function class? Dia sebenarnya adalah the unit function yang tadi minus shiftkan dia kepada
Doktor, PT tu dia rotate lah.
This is not PT, this is for DT. Kita talking about DT dulu.
Oh, okay.
Okay, so this is DT. Saya nak, I'm asking you just now. So if we have DT, this one, this figure, square pulse kat sini, satu unit square pulse. If you want to rewrite it in terms of the unit impulse, it is actually macam gini ya, the UT, and then kita minuskan dengan this is UT. And then kita belajar pasal shift, right? This one adalah UT minus ke plus?
Minus.
Minus 1 So kalau pergi ke sebelah kanan, remember? Shifted to the right.
Yes.
T minus 1. So kalau kita combine, kita akan dapat this one lah. Betul?
Yes, correct.
Okay, so this is the description of our DT ya. So DT tu yang dia cakap tu, UT adalah UT minus UT minus 1. Okay. Okay, now dia suruh kita express PT in terms of DT. Okay, so sekarang we know that our PT is here. Okay, so apa yang kita tahu pasal PT di sini? Kelas?
UT minus 1.
Ya, apa dia? Dia bagi sini adalah this one. Okay.
So
this
PT equal to
in terms of dt, dia kata in terms of dt. Kalau kita comparekan PT in terms of dt, so our PT yang ni dia sama dengan dt and then
minus T minus 1.
minus
DT
d
minus 1.
Okay, so in terms of the square equation like this, kita panggil ni untuk memudahkan macam konsep apa 1010 lah, 10 minus 1 and so forth. So yang ini kalau kita tengok di sini, it is 1 and then minus 1. Okay, dan the apa dipanggil arrow is actually refer to at t equal to 0. Yeah. So kalau if you look here at t equals 0, the signal here is 1, and then when t equal to 1, yang ni bila dia 1 lah, dia adalah negatif 1. Okay, understand this one? Okay, so now when we understand the how to express, okay, now we have B, kita ada this system. Okay, this is an LTI system, and then we have another system B, part B ni. But then the systems hold the same expression as the LTI system above, yang atas. So now we have a different input. Our input now is one minus one minus 1. Okay. How are we going to find our YT? So YT macam mana kalau kita based on the relationship just now?
PT minus PT open interval negative minus 1.
Kalau kita tengok kat sini, so if we have our dt equation, saya katakan lah. Okay. So if we have equation dt yang ini, so our output PT is this one. So if we rewrite this and then we also know that this one is represented by, bila kita ada dt minus 1, it is represented by this. Okay. So for this xt, kita ada 1 minus 1 minus 1. When it is represented by the ut, because it is the input, it holds, dan sini adalah masa dia 0. So it is actually in terms of the input dt minus dt minus 1. Okay, so ini masa t equal to 1, ini masa t equal to 2, and the amplitude is negative. Okay, dt minus 2. And then whatever di sini, kalau kita punya input just now, so it will be the same case for the output. Okay, so kita punya output saya dapatkan output dulu. So in terms of output, output is our here dt, pt, sorry. So our yt in terms of the output p, sebab kita ada to give. Okay. Terbalik-balik tadi, it depends on the this equation lah, t minus t dan juga minus t to t. So in terms of pt, dia adalah pt same as whatever the input that we put, p t minus 1 and then minus p t minus 2. Okay, so this pt, kita tengok kat sini, pt kita adalah 1 minus 1. What about when pt minus 1? Okay, bila dia shift, so dia masa dia 0 tu dia adalah 0. Okay, so tak ada ni, saya punya pt tadi. Okay, saya buat di sini. Give this type of input. The output. Okay. So kita learn about time shift. So bila pt minus 1, macam mana rupa gambar kita? Dia shifted. Okay, tak ada kawasan tak. Okay, tak apa. Saya bawa kat sini lah. I just show it here. Okay, dia akan shift kan. Okay, signal kita this one. But when we do this representation, dia mesti start dengan 0 because we want to add later on. Kita kata tadi convolution tu dia adalah integral addition. So 0 and then 1 and minus 1. 1 and minus 1. The same for P2. Sekarang P2 dia shift kepada 2. This is 1. Bila P2 dia 0, 0, 1 and minus 1. Sampai sini faham tak kelas? Finally, our yt will be, bila kita nak kira, when we want to add, it will be 1 minus 1, 0, 1 minus 1. Sebab ini semua refer pada t equal to 0. And then, ni tolak, minus this one. Then minus 0, 0. Alamak, tak muat dah pula. Okay. Ini sekejap, saya padam sikit. Ni dekat 0, ni dekat 1, ni dekat 2. So 1 and minus 1. So bila kita campurkan semua, that's where we have 1, 1 minus 1, 2, 1 minus 1 is 0, minus 1 plus minus 1 and 1. Okay, so this is our output. Boleh? This is the concept of superposition in the LTI system. Okay kelas, boleh tak? Siapa yang ada kelas pukul 3, you may leave now sebab saya rasa tak habis ni. So I have to continue. Semua ada kelas pukul 3 ke?
I actually got
Only one, right?
yes.
Yang lain tak ada kelas kan? Because actually based on your timetable, you have 2 hours. Saya terpaksa extend sikit sebab kita tak habis lagi ni. Okay, I need what you need to do. Okay, siapa yang kena keluar tu tak apa, you are allowed to leave.
Sorry, Prof. So sorry, Prof.
Okay, it's okay.
Prof, actually this today class is until chapter regarding Laplace transform only, is it?
No. Kita Laplace lambat lagi. Laplace I think week 5 kot. Kita fahamkan dulu konsep superposition. And then next week kita akan masuk lagi superposition, chapter 4 superposition and convolution. And then I think week 5 tak silap. Next week is week 4. And then we Laplace masuk tak silap saya minggu ke-6 dan minggu ke-7. Lambat lagi. So kita kena fahamkan dulu because just now saya mention about the impulse response kan. Impulse response you have to really understand about the concept of superposition and convolution. Lepas ni kita akan buat convolution, lepas tu baru Laplace.
Okay, thank you, Prof.
Okay. Okay, so this is on actually superposition dulu. Convolution pun sama je lebih kurang, tetapi kita kena fahamkan yang konsep ini dululah. So far okay class? This is the initial system tu dia nak menunjukkan the relationship lah, the impulse response of the system. So the input is dt. dt dia kalau kita buat dalam equation unit function, it is actually ut minus 1 yang saya terang tadi lah. Okay, so ut lepas tu tolak dengan yang ni, jadi dia tinggal yang ni je lah kan. Kita ada ni, lepas tu kita tolak ni. So nanti balance ni hanya this one. So with this dt, with this input, we have the output like this one. Okay, which if represented by dt, bukan ut by dt, it is 1 minus 1. Dia refer balik sini lah, superposition. So kalau kita buat dalam bentuk equation in terms of bracket ni, dia adalah 1 minus 1. 1 sini refer pada at time equal to 0. This one at time equal to 1. Okay, now the question is, we have another system lah, input dia xt adalah 1 minus 1 minus 1. Using superposition, find yt of the system having the same responses as the given LTI tu. Okay, so what we do first is that we know that xt, if given with this equation 1 minus 1 minus 1, bila kita describe in terms of the input LTI dt, it should be, yang ni adalah masa 0, this one masa masa 2, and then this one masa 3, shifting, left shifting, and then the amplitude is minus. So xt in terms of dt is dt minus 1, dt minus 2. Therefore, if dt this one, meaning using the superposition, our yt in terms of p adalah this one. Okay, now to find what is yt in terms of pt ni kita masukkan lah. So kita sekarang dah dapat relationship. This one is actually the relationship and the superposition tadi. And now putting that pt tu, the value of kita punya tadi itulah pt tadi So 1 minus 1, 0, 1. Sebab ni dah shift kepada 2. So finally we have this one bila kita add up. Okay. What about example part C? Part C kita punya xt is dia lebih. 1 minus 1 minus 1, 1. So what is YT in terms of the input? Plus dengan D minus D T minus 1 minus dt minus 2 plus d plus because of the amplitude t minus 3. Therefore our yt is pt minus dan seterusnya lah. PT minus 1 minus PT minus 2, saya tulis lambat lah, plus PT T minus 3, and then kita put the P punya setiap satu sini, 1 minus 1, and then 0, 1 minus 1, 0, 0, sebab dia dah shifted pada to the right 2, and then shifted pada 3, and then add up, kita dapat this one. Okay? Dah letih? Kalau dah letih yang lain saya sambung next week lah nampaknya. Ataupun can I go another one?
Okay.
Another one ni kalau if you I tried to visualize in terms of tables and matrix. Chapter problem 6 in terms of table, problem 11 in terms of matrix, supaya you all nampak senang nak calculate. Okay, so I just show you one, and then cuba balik after this, figure it out, and then kita akan discuss further on Monday. Okay, for example like this one. The signal is given in terms of accumulator. Kita baca pasal accumulator just now. It is the input is k equal to 0 up until 4. Okay, jadi bila kita buat equation xt kita impulse dia t minus 1, minus 2, minus 3 dengan minus 4. Sebab dia adalah accumulator and then dia adalah summation. So the amplitude are all positive. So therefore bila kita buat dalam bentuk bracket, it is 1 sampai 5 lah. Ni masa t equal to 0, 0, 1, 2, 3, 4, 4. Tapi dia ada 5 values kat sini and all are positive. Why? Because the accumulator. And then given that dia kata first case dia punya impulse response is given like this one. Delta t minus 1. So kalau kita buat in terms of bracket, it will be 1 minus 1. Ini masa T0, this one masa T1. Negative 1 ni maknanya dia shifted right 1. And then the value here, minus. And then kalau nak macam ni tadi saya tulis, I write it. Kan? Tulis satu-satu. But then try to visualize something like this. So we have our input in terms of this one, the impulse t minus 1 sampai 4, and then our impulse response h tadi tu adalah h1 sampai ke h4 tadi, sebab kita punya ni sampai 4, therefore our y2 sepatutnya pun sampai 4 lah. So yt dia akan ht plus ht minus 1 sampai ni lah, sama So kalau kita buat sebelum tadi kan, xt yt, kalau xt ni dt, yt tu pt lah. So dalam our case yt ni akan ht plus ht minus 1 up until ht minus 4. So bila kita lihat satu-satu ht tu adalah at current 1 and minus 1. Bila t minus 1 dia shifted di sini dan dia adalah positif. The shifted next one tu dia jadi negative. Kalau kita bayangkan dalam bentuk matrix, the next example tu saya tunjuk dalam bentuk matrix. So plus, minus, plus, minus, plus, minus and so forth. Okay, so bila kita nak dapatkan y, when we want to determine the output, it will be the summation of all this. So sini ada satu di tau, so maknanya ni masa t equal to 0. This one sebab dia semua adalah plus, so summation minus dengan negative and positive 0, 0, 0, 0. This one minus. So therefore, what our output 1, 0, 0, 0, 0 minus 1. Okay, so please please read and try to understand for 6B. Sama je, tinggal lagi 6B tu dia punya apa? H tu different lah. Tapi dan ada value 2 kat sini. Tu ada minus and plus. Please try to understand what. Ataupun alternatively, if you tak nak tulis, terus tulis 1 in terms of 1 and 0. Saya buat dalam bentuk 1, 0, 1, 0 di sini. And then okay, so please try for 6B, and then another example yang saya tunjuk di sini adalah on chapter 11, tapi chapter 11 ni the way kita tackle dia adalah dalam bentuk matrix. Also the same concept. Okay, so I will explain later lah yang especially yang the last one tu on Monday because Monday tu kalau boleh kita terus masuk chapter 4 on superposition and convolution.